Hi, welcome to the new video, and we are going to discuss how to perform one-tailed t-student test. So we are going to consider the same problem as in the previous video. We know that the value of observations is equal to 25, and we know the values of mean and sample standard deviation. We assume the value of alpha of 0.1. But this time we want to investigate whether the average score is bigger than 100. So please recall that when we performed two-tailed test, we were not interested in whether the value is bigger or smaller than some hypothetical value, 100 in this case. For us, it was enough to know that it was different. And in both situations, I mean when the true mean score is bigger and when the true mean score is lower than 100, we could successfully reject the null hypothesis. This time we are more specific, so we want to check whether the average score is bigger than 100. So naturally, we are going to formulate the null hypothesis and alternative hypothesis in a different way. So now the alternative hypothesis would state that the average score is bigger than 100. Like this is our specific area of interest. And the null hypothesis, consequently, would state that the mean score is smaller than 100 or equal. And this time we are going to analyze only right tail of the distribution. So we are interested in whether the average score is bigger than 100. So we are not interested in the left tail, but in the right tail only. That's why this kind of one-tailed test is called a right-tailed test. Also, because there is no need to consider both sides of the distribution, we do not have to split our alpha by half. And that's why when we analyze the critical value for computing the rejection region, we are going to take alpha as it is. So please remember that we have 24 degrees of freedom. The value of alpha is 0.1, so the corresponding t-value is 1.318. Again, please notice that it's smaller than for two-tailed test we performed before. That's why it can be, and actually it's kind of common, when you fail to reject the null hypothesis based on two-tailed test, but still you manage to reject the null hypothesis based on one-tailed test. And I'm really emphasizing this right now because for students it's kind of counterintuitive. Like, I can prove that x is bigger than y, however, I cannot prove that x is different from y. Sounds illogical, but again, when you keep in mind those critical values, it's not that contradictory as it might seem to you. So, our rejection region is everything to the right from the critical value, which is 1.318. And we know that we can only reject the null hypothesis when t-statistic we compute is bigger than 1.318. So computing t-statistic, basically it makes no difference for one-tailed test and two-tailed test. Yeah, pretty identical. So now we can go back to the t-distribution with rejection region, and here we conclude that we failed to reject the null hypothesis because t-statistic does not go within the rejection region. So even though they are pretty close, it's not enough to say that the average score is bigger than 100, and this difference is statistically significant at 10% significance level. So at least for our chosen value of alpha, we fail to reject the null hypothesis. Now let us imagine that our research task is slightly different and we want to investigate whether the average score is smaller than 100 points. Again, I know it looks kind of ridiculous because you see that mean is 103, so obviously it cannot be smaller than 100 points, but sometimes you need to do things like this, like you're gonna see it later. Okay, so as before, we formulate the null and the alternative hypothesis. So here our alternative hypothesis or hypothesis of interest states that x bar is smaller than 100, and the null hypothesis, the complementary one, states that x bar is bigger than or equal to 100. So the critical value will be the same, although now we are interested only in the left-hand side of the distribution. That's why what we are performing is called left-tailed test. You go for it when you need to check whether mean is smaller than certain value, contrary to the right-tailed test, which is performed when you want to check whether the mean is bigger than certain value. So the value is the same, although our rejection region will be located on the left-hand side of the distribution. So yeah, here we have only one rejection region, and this rejection region is everything to the left from negative 1.318. Again, we compute t-statistic. It's not different. It's not affected by whether you perform one-tailed, two-tailed, right-tailed, or left-tailed test. It's still the same. And we can definitely say that it does not go within the rejection region. So that's why we fail to reject the null hypothesis, because there is no sufficient evidence for rejecting the null hypothesis, at least for the value of alpha we have chosen. It might be possible that if we are less restrictive and we are more tolerant to type 1 error, so we assume bigger value of alpha, we would actually manage to reject the null hypothesis. So yeah, please keep in mind that to a great extent, conclusions from your test are dependent on the assumed value of alpha. So that was it. In the next video, we are discussing some more examples for using t-student test. Hope you enjoyed this one and thank you for watching.